Hello, and welcome back to Chemistry 101. My name is Camille Keene, as you well know, and we will be delving into the concept of Q equals mc delta T. When further delving into this great, fantastic equation, we will be able to conduct two labs. The first lab is determining the calorimeter constant. Now this may seem like, what is a calorimeter and what is a calorimeter constant? But we will further explain, no worries. Our second lab is determining the specific heat of an unknown metal. You will be able to do this using this great equation. Okay, so as I was explaining before, we have this great equation, this fantastic equation that helps us understand the whole idea of thermodynamics. This equation is Q equals mc delta T. What is delta? Delta just means the change. So in this equation, you may be wondering, what are all of these different variables? Well, the first is Q, which is the amount of heat either given off or absorbed in an equation. This is normally measured in joules, not the blingy bling, but just joules, as in work of heat. The next variable in the equation is M. M stands for the mass. The mass can normally be calculated in grams or kilograms, depending on what you feel that day. The C in the equation is representative of the specific heat of the substance. For example, water has a high specific heat, one of the highest. It is measured in joules per gram degree Celsius. Water has a high specific heat because it takes 4.18 joules to raise it 1 gram of the water 1 degree Celsius. I repeat, the specific heat of a substance is the energy it takes to raise 1 gram of that substance 1 degrees Celsius. This temperature is measured in T final of the temperature of the substance minus T initial, which is the initial temperature of the substance.
So overall, this equation shows you that the heat given off or absorbed is equal to the mass of the substance times the specific heat of the substance, which is the amount of energy required to raise the 1 gram of the substance 1 degree Celsius times the change in temperature, T final minus T initial. And this once again equals the heat absorbed or given off. So let's now delve into our first experiment, which will tie all of these concepts together.
So in the first lab, we will be determining the calorimeter constant, which is the C in the mc delta T. This is determined by using two different samples of water. One is warm water that is heated, 100 grams of it, which is equal to 100 milliliters. And the other one is a cold, normal room temperature water of 100 grams, which equals 100 milliliters. Our calorimeter today will be a coffee cup, just a regular coffee cup, a styrofoam one. When the two different waters, 100 grams of a hot water and 100 grams of a cold water, are placed into the coffee cup calorimeter, the temperatures of both will change. T final in this situation will be equal because the initial temperature of this one was very warm and the initial temperature of this one was room temperature. But when you put them two together, they have the same T final, which will be in the middle of these two temperatures. So when this happens, the Q on one side will be positive and the Q on the other side will be negative. And this is measured in joules. In order to do this, we have the mass of both waters, which is 100 grams. The C of both waters, which is given to us, which is 4.18 joules per gram degree Celsius. And the delta T, which is the T initial, or the T final minus the T initial. So, as you can see, this is a lot of information. It's hard to take it all in, but we just got to roll with it. So first, the mass of both of them, as I said, was 100 grams of water. The specific heat, it does not change in the liquid state, so it's both 4.18 joules per gram degrees Celsius. That's a given. We didn't have to calculate it. The next, well, the T initial for the cold water we measured using a thermometer, and it was 22 degrees Celsius. But for the hot water, we heated it on a heating plate, so this turned into being 59 degrees Celsius. After we put both of the waters into the coffee cup, the temperature changed for both of them to being the same value because they're both mixed into the coffee cup. This was 41 degrees Celsius for both of them. So, once we have all of this glorious information, it will be easy to calculate the Q, the amount of heat that is either absorbed or released during the equation. This is through Q equals MC delta T.
Q of the cold water equals M, 100 grams, times C, 4.18 joules per gram degree Celsius, and delta T, which is T final, 41 degrees Celsius, minus T initial, 22 degrees Celsius.
And from my crazy calculation in my brain that I just did right now, it only took about 2.2 seconds. It equals 7,942 joules. So 7,942 joules were absorbed by the cold water. And we have the 100 grams, which is the M in Q equals MC delta T.
Now we will multiply the 100 grams by the specific heat, which is 4.18 joules per gram degree Celsius. That's a given. You don't need to calculate it. It's just a given. But next we'll calculate the delta T, which is the T final, which is 41 degrees Celsius, minus the T initial, which is 59 degrees Celsius.
And right now you're probably thinking, wow, the 41 degrees is less than the 59 degrees. So it's going to be negative. But that's okay, because in this experiment, the warm water released energy. And when it releases energy, the joules end up being a negative number. So the heat given off is always a negative number. I repeat, the heat that is given off is always a negative number. And through my crazy mathematical brain, I was able to figure out in about 2.4 seconds that the amount of energy needed was released during this equation and this reaction was negative 7,524 joules. That's right, joules.
Q of the cold water, which is 7,942 joules, coupled with the Q of the hot water, which is negative 7,524 joules. Coupled with them together, you add them together, it will equal the Q of the calorimeter. You're thinking, why do I need the Q of the calorimeter? Well, we'll just see in a quick sec. So now that we have these two values, the Q of the cold and the Q of the warm, we subtract them to find the Q of the calorimeter. And this is equal to 418 joules. I'm sorry that calculation took so long. My brain's a little fuzzy right now.
And now that we have this value, we recognize that C's labels are normally joules per gram degree Celsius. How are we going to get that? We divide by the delta T of the cold water. Why only the cold water? Because the cold water was at room temperature and the coffee cup was at room temperature.
So we divided by 19 degrees Celsius, and this equals 22 joules per gram degrees Celsius. And this is equal to the heat capacity of the calorimeter.
And we are completed. We have finished lab number 1. I hope you've enjoyed Chem 101. Please stay tuned for the next episode, which will continue in 3, 2, 1.
Camille, Stepped out for the time being, but we're going to continue with our labs. Part 2, determining the specific heat of the unknown metal. In this experiment, we will be using 2 different waters. One water will be recorded at room temperature, and the other water will be placed on a hot plate, and the temperature of that water will be then recorded. When the water has reached a specific high amount of heat and it is almost boiling, you will put the metal into the warm water and you will record the temperature of the warm water. Then you will place that piece of metal into the room temperature water and you will record the temperature of that.
The mass of the metal was 9.7 grams and the mass of the water was 100 grams. The specific heat of the metal is what we're trying to find, and the specific heat of water is 4.18 joules per grams degrees Celsius. The initial heat of the metal when heated was 92 degrees Celsius. The initial temperature of water at room temperature is 22 degrees Celsius. The final temperature of the water when the metal was placed into it is 25 degrees Celsius. This will be the T final for both equations.
In order to find the Q of the metal, you need to determine the Q of the calorimeter and the Q of the water. So now we will determine the Q of the calorimeter. The Q of the calorimeter equals C cal times delta T. In the previous lab, we determined the C cal to be 30.91 joules per degree Celsius.
Go.
The delta T we are using is the final minus the initial, because the calorimeter is at room temperature like the water. The difference we found is 3 degrees, which we then multiply by the C cal to give us the Q cal, which we found to be 92.73 joules. We now have the Q cal, which is used in the equation to find the Q of the metal.
The Q cal is equal to 92.73 joules. Now we are going to find the Q of the H2O. The Q of the H2O is equal to
MC delta T, which is equal to 100 grams times 4.18 joules per gram degree Celsius times 25 degrees Celsius minus 22 degrees Celsius. This value of Q2O is equal to 1,254 joules.
Now we can put this into the equation to figure out the negative Q of the metal value.
So we're going to take out this Q of H2O and plug in 1,254 joules. The negative Q of the metal is going to be equal to MC delta T, which will be 9.7 grams times X for the specific heat we're trying to find, times 25 degrees Celsius minus 92 degrees Celsius. Okay, so the total joules is 1,346.73 is equal to 649.9 grams degrees Celsius.
And therefore, X is equal to 2.072. So this number is our final answer and the specific heat of the unknown metal.
And this concludes Chemistry 101.
Oh my god.
T double T, M C double T, M C double T. Let's get rid of the dog.
Okay.
And say you don't know what that hotline blames.
Okay. No. No. Oh, it's the Q! The Q of the cold water, which is 7,942 joules, added with, no, the C, ugh! The, case positive, ugh! This is, I messed that up.
We're rolling. Oh my gosh. Okay.
Bill, can you give me 5 seconds?
My favorite rapper is Missy Elliott.
Joules. Alright, so now do you have the part one up there? Okay. Hello and welcome back. Start again. So in this equation, you may be wondering what all the blingy bling. Pause it. Shh.
Sign exclusive.
Where are you?
Where's your phone?
Okay, everyone, we're
Point on
shooting.
the set.
Okay, go.
Nope.
The initial temperature of water at room.
Okay, pause that. Hello and welcome back to Chemistry 101. My name is Camila.
Alright.
And this concludes.
Elsa!
Delete that video so you know not to use it.
Okay, ready, go. Pelgreen!
Pill, you have to be silent!
Silence.
These are bloopers. Q equals MC delta T.